In this video, we're going to talk about vertical motion under gravity. One scenario could be a ball dropped. Notice that the motion is always in that plane, so it's either up or down. It could also equally be a ball that's been thrown directly up. Notice there is no horizontal, it's always vertical. So in this scenario, I have a ball, it's being dropped from stationary, so my vector is 0 at this point because it's been held in place. Then it's dropped, and now I'm started drawing my velocity vectors. Notice that there's arrow and also the size, and as the ball goes further down, the v is increasing. So you can see my arrows get bigger and bigger the further down I go. My acceleration, I can draw another vector for acceleration, and it will be a. Note that it's different from the v. The v vectors, the velocity vectors, are getting bigger and bigger, but my acceleration vector is constant throughout the whole journey. This acceleration is caused by gravitational pull and is always constant. Another thing to notice is that the velocity vector's direction and the acceleration vector is the same. When this happens, the velocity increases. So when the ball is dropped, the velocity is going to keep on increasing because it is in the same direction as the acceleration vector. And I'll repeat this again. The acceleration vector is constant, so it's the same for everywhere for the ball to go from the top to the bottom, while the velocity vector is increasing. In this scenario, the ball is thrown up, so it will have a velocity vector going up. As the ball keeps on going up, the velocity vector is getting smaller and smaller, and at the very top it stops. Just like the before scenario, acceleration vector, it's always pointing down because of the gravitational pull and is constant. But now the velocity vectors are getting smaller and smaller, and when it gets to this point it stops. Notice that the velocity vector and acceleration vector is in opposite direction. So in summary, if the velocity vector is in the same direction as the acceleration vector, then the velocity will increase. While if the velocity vector is opposite to the acceleration, then the velocity will decrease. So you can also put these together. So if someone throws the ball up and down, so in this case the velocity vector is decreasing because the ball is being thrown up and is going against the acceleration due to gravity. And when then the ball goes up, then it comes down. So the velocity vectors are increasing because they are in the same direction as the acceleration vector. And the important thing to note as well is that these are in one plane, up and down. Notice there is no horizontal motion. We'll talk about horizontal motion later on.